Hello all, in this lesson we're going to be studying how to name organic compounds, and this is going to bring up some very new ideas for us, including isomerism, alkyl groups, counting carbons, and counting multiple carbons. So this is the bookwork that we'll do with the class. Its number is 19, 21, 23, 27, 29, 31, and 33 on pages 200 to 201. And the aim today is what are isomers and how do we name them? So the first thing we have to study when we start this lesson is the concept of isomerism. I suggest at first that we write the chemical formulas or the molecular formulas for each of the compounds here. And you can basically just count the atoms. There's 1 carbon atom, 2, 3, and 4 carbon atoms. So C4 will start out our molecule, and when we count hydrogens, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm getting C4H10. When you look at the next molecule, you're also going to find C4, 1, 2, 3, 4, and the H's are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So also C4H10. So if they have the same molecular formula, are these two molecules the same molecule or could they be different? And I suggest looking at the structure to answer that question. In the first molecule, you have a structure that is sort of T-shaped. You have a horizontal carbon chain with a vertical carbon attachment. And in the second molecule, which I'll do in blue, it's really just a straight chain of carbons. So I would say these molecules are different based on their structures. So if you are two molecules that have the same molecular formula, but you have different structures, then you're called an isomer. And that's the basics behind isomerism. So when challenged to name these two molecules, a lot of us would choose butane for both. The reason is because of the general formula. We see C4, so we would think bute. And we note that 4 times 2 is 8, and 8 plus 2 is 10, so we would probably put an ane as the ending. And for the next molecule, we would do exactly the same thing. Bute for the C4, and ane for the H10. But only one of these names is correct for the molecule, because these two molecules are different, so they shouldn't receive the same name. And if you were thinking that this is the one that's not going to be butane, then you would be correct. This one down here is the only one that would correctly be named butane, and in fact we can call it normal butane. All right, and our last challenge question on this slide is to take a look at this molecule down here. And here's the question: is this molecule an isomer of pentane? So a molecule that would be pentane would have to have 5 carbons, and when you check this molecule, you can see 1, 2, 3, 4, 5 carbons. So that part of the name does check out. And if it's going to end in a suffix ane, then it needs to follow the general formula CnH2n plus 2. So let's count our H's while noting that if it's truly pentane, that we should be seeing 12 H's because 5 times 2 is 10 plus 2 is 12. All right, let's count. You have 2 hydrogens on every carbon, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at H10, we cannot say that this is an isomer of pentane, so I'll say no to that part. And the reason is because in order to be an isomer, you have to have the same molecular formula. You cannot have a different molecular formula. And therefore, as a result, it is not an isomer of pentane. Here's another new thing for you guys, and this refers to something called an alkyl group. An alkyl group is basically just a little branch on a chain of carbons in a molecule. So when I think about the meaning of a branched chain, I often think about a charm bracelet. Here's my sketch of that. The bracelet itself would form the chain of the bracelet or of the molecule, and the charms would represent branches on the chain. So it's pretty clear that this is the main idea, but you do have these small attachments that add meaning to the bracelet. And when we have a molecule with attachments, we can think of these small things as charms in a way because they're adding meaning to the general molecule. So when we do these names, we do need to first assess what is the main part of the molecule. And then secondly, we have to assess what is the branch. We basically name each of those things individually and we put them together in a specific way to get the entire name of the whole molecule. So first stop on this crazy train is to first name the chain. So our chain has 1, 2, 3, 4, 5 carbons. So it's going to receive the prefix pent. So I went ahead and put that in here. And the last part of that is going to be an ane. And the reason is because we have all single bonds between these carbons. So we'll just say pent-ane. The ane, again, is reflecting all the single bonds. Now we need to name the branch. So this appears to be the branch right here. It has only one carbon, so we will use the prefix meth for that. And the suffix is not going to be ane. You only give the suffix ane to the chain, not the branch. And the suffix YL is what we give to branches. So it'll be methyl pentane as basically the answer. So I highlighted that below the name methylpentane, but I would point out that that is not very specific. And basically what I'm getting at here is that the methyl group is attached to the middle carbon of the pentane chain. But the methyl group could have been attached here to this carbon or to this carbon, and that would have changed the name considerably because it changes the structure of the molecule. So on the next slide, I'm going to teach you how to deal with that idea of recognizing where the branch is and including that in the name. So as we begin to learn how to count carbons in order to specify the location of a branch, there are two things that I need you to consider before we do anything. And the first thing that you have to consider is what is the chain and what's the branch? So in short, the chain is going to be the longest unbroken chain. So for instance, in this molecule, the longest unbroken chain is here, as opposed to, let's say, here. This is a chain, but it's not the longest unbroken chain. So the longest unbroken chain is whichever one is literally longest and you don't have to like skip a carbon to get to the other side. So the chain in this case is 1, 2, 3, 4, 5, 6, 7 carbons long. So part of our name is going to be heptane. And before I forget, let me just say that the chain is the longest unbroken chain. Put that in here. So we had already determined that part of this name is going to be heptane, and another part of the name is going to be methyl, because there's only one carbon on this branch. And again, the YL suffix on methyl indicates that this is the branch, so a 1-carbon branch on a 7-carbon chain. And just to be really organized, I'm going to highlight the chain and highlight the part of the name that the chain refers to. And I'll also highlight the branch, and I'll put the part of the name that refers to that as well. Now, there's one more part that we have to do, which is we have to locate exactly where on the chain the branch is. So the branch is definitely on this carbon, but what I want you to think about is where is the carbon? Like, is this carbon the 3rd carbon in from the left, or is it the 4th carbon in from the right? And I encourage you to count from both directions, so we'll do that now. So from the left, we have 1, 2, 3. If we came from the right, it would be 1, 2, 3, 4, 5. So what we're really determining is, are we going to choose a 3 or a 5 to represent what carbon this branch is actually on? And what you should always, always, always do is you should always choose the lowest number. So my final answer for this name is going to be 3-methylheptane. And I'll highlight the 3 because that was part of the location of the branch. All right, so always choose the smallest number after counting in both directions. And remember that the chain is the longest unbroken chain of carbons. So using that, I want you guys to take a little bit of time right now and write down what you think the name of this molecule would be. First, find the longest unbroken chain. So the question is the chain going to be this guy, which is sort of the obvious answer for many of us, or is there a longer chain than this? This one has 1, 2, 3, 4, 5 carbons in it. So let's see if we can find a chain which has more than 5 carbons. I have actually found one. I found a chain that has 1, 2, 3, 4, 5, 6 carbons, which is the longest unbroken chain available. So let me highlight that in red. So here is our longest unbroken chain. This forms basically the end of the name, and I said there were 1, 2, 3, 4, 5, 6 carbons. So this is going to be a type of hexane. But again, we do need to identify the branch and its location. So first of all, the branch is here. It's clearly a methyl branch because it has only 1 carbon. And to get a firm location, we need to count the carbons from both directions. So starting at the top, we have carbon 1, 2, 3. And if we started from the right, we would have carbon 1, 2, 3, 4. So we have to decide, are we going to choose carbon 3 or carbon 4 as the address for the methyl group? And everyone would agree that we should choose carbon 3 because it's the lowest number. So the answer is going to be 3-methylhexane. And just like in the last one, for organizational purposes, I'll highlight the 3-methyl in blue to dovetail with the diagram. And I'll highlight the hexane in red to also show where that came from in the diagram. So just to round out this slide, the molecule above was 3-methylheptane. And the molecule to the left was 3-methylhexane. Now remind me to show you this slide in class because I have an animation that can really highlight some of the key differences. I almost feel bad showing you this slide because we're going to have to name multiple branches on this slide. I went ahead and highlighted some of them to help us understand the branches that I'm looking at. So we have a green branch, a yellow branch, and a red branch, all of which need to become a name. So when we name these, a lot of it's the same. We're still going to find the longest unbroken chain, which is highlighted in like a violet color here. And then after that, we need to name the branches. And in this case, there are 3 identical methyl branches, a CH3, a CH3, and another CH3, which has been condensed here just to save space. So before I go too far, I just wanted to go ahead and say that we have a pentane for the longest unbroken chain. And there are 3 methyl groups, so definitely methyl is part of the answer. But since there are 3 methyl groups, and this is the first time we have more than one, since there are 3 methyl groups, we need to put a prefix in front of the methyl to say how many. The prefix that we're going to use in this case is tri. Trimethyl means 3 methyls. So far, I know that we have a pentane parent chain with at least 1 methyl group, and then going further, I can see it's 3 methyl groups. So 3 methyls on a pentane. But the only thing I would want to add is where those methyls are. Now, there are different addresses, like this methyl group is on that carbon, and this methyl group and that methyl group are both on this carbon. So how do we deal with that? It's actually the same as like a typical one. We just need to count from both sides and choose the smallest total of numbers. So from the left, I have a carbon 1, 2, 3. If I go from the right, I have a carbon 1, 2, 3, 4. So we're either going to go with the option, let's see, a 2, 3, 3. And this is the format we would use for that possible answer. Or if we don't use the 2s and the 3s, we would use a 3, 3, 4. So I alluded to this earlier, but the one you're actually going to choose is going to be the one whose numbers sum to the smallest number. So a 2 plus a 3 is 5, plus a 3 is 8. But a 3 plus a 3 is 6, plus another 4 is 10. So we have a total of 8 versus a total of 10. And that's the reason why you would eliminate this answer choice, and your final answer would be 2,3,3 trimethyl pentane. Now in the next step, I want to name this molecule. So we have a 1, 2, 3, 4, 5, 6 carbon parent chain. So let's give this the ending hexane. And it looks like we have 2 branches, one branch here and one branch here, both of which are methyls. And since there were 2 methyls, 1, 2, I'm going to put a prefix di in front of methyl. And we have one more job to do, which is to locate both of those methyl groups. So 2 methyl groups on a hexane, and location time. So I have 1, 2, 3, 4, if I come from the left. And if I come from the right, I have 1, 2, 3, 4, 5. So our 2 choices are going to be either a 2, 4 dimethylhexane, or it's going to be a 3, 5 dimethylhexane. So which one seems right to you guys? 2, 4 or 3, 5? So if you chose 2, 4, then you're right, because 2, 4 has the smallest sum. 2 plus 4 is 6, whereas 3 plus 5 would be 8. So 2, 4 dimethylhexane would be the answer. And with that, we have reached our pair up. You guys did a great job in this lesson. Copy down these questions without answering them, and we'll do them in class. And then copy down these summary questions without answering, and we'll do them in class as well. I hope you learned something, and thanks for watching.